So matrices and determinants today, whatever that might mean. Does anybody know the word matrices? What if I tell you that's the plural and the singular is matrix? Does anybody know anything about what a matrix is? Well, okay, tell me something about the movie that might apply to this class. Okay, so yes, computers use matrices a lot in the programming. A matrix is simply a bunch of numbers or variables that can stand for numbers that are arranged in a rectangle. And there's a lot of times when computers are analyzing a whole lot of data, so like you've got a table of data, all of these rows and columns, that's a matrix. Singular is matrix, plural is matrices. So here are a bunch of examples of matrices. Something that would not be a matrix that's not arranged in a rectangle, so that would not be a matrix. But you see how all of these are. All of the rows and columns come out evenly. Sometimes we will have brackets, so where it turns a little corner at the top and bottom. Sometimes we won't. That makes no difference. On the next slide, we are going to see a little bit different symbol that does mean something special. But if there's square corners or no brackets at all, it means the same thing. Now, each of those numbers or variables in a matrix is called an element. And the dimensions are the rows by the columns. And the order matters on that. So this last one row straight across, a second row straight across, so 2 by, and then we have 4 columns going up and down. That one is not a 4 by 2. It is a 2 by 4. This one would be 3 rows and 1 column. This little teeny tiny one is a 1 by 1. This one, 3 by 3. Let's go ahead and label the others. How big is this first one, everybody? It has to be rows first, so 2 rows going across, 3 columns. Okay, what about this one? That one's easy, 2 by 2. And this one? 1 by 3 is how we read that. The X we read as a by. Now, the 1, 1, the 2, 2, and the 3, 3 are special because they are all square matrices. And we're about to do something that we can only do if it is a square matrix. We are only going to do this for 2 by 2 matrices. A little bit later on this semester, we'll learn how to do this for 3 by 3s. So a determinant can be found for a square matrix. So here's our other vocabulary word. When we have those vertical bars that look like giant absolute value bars, no square corners on it. When they're just straight like absolute value bars, that means the determinant of this matrix. And all that a determinant of a 2 by 2 is this diagonal AD minus the other diagonal CB or BC. Now, are 5 and -5 the same number? So if we switch that around and we take the opposite of that, it is not the determinant. We cannot do BC minus AD. We must do the diagonal first that goes from top right to bottom left, minus the one that goes from bottom left to top right. And sometimes students find it helpful to remember which one is which by thinking about a matrix on top of the United States. And we're going to go from left to right for both of these because that's how we always read. If we go left to right for this diagonal starting up in the northwest, and we go down through AD, we end up in the nice, warm, sunny southeast where the temperature usually stays positive. So the AD one is the one that it is plus whatever that is. If we do the other diagonal left to right, we end up in the cold northern border, almost in Canada, or if we have it over here up in New England, where the temperature very often does hit negative numbers. So that's the one that needs the minus sign in front of there. So if that helps you remember it, use it. If not, if you do better, just remembering this way minus the other way. So let's try a couple of examples. So first one, we have to go top left to bottom right, which means we need to take the -4 times the 7, and then we need to subtract the second diagonal. The second diagonal, bottom left, top right, is going to be 2 times -3. So what do I have? -28 minus a -6 becomes a +6, so that we have how much? First line is optional. That helps you write it down, but I definitely want to see what do you get for the first diagonal minus what do you have for the second diagonal. That will help me if there's a mistake to help figure out where the mistake is so that you can figure out what you need to do to fix it. Okay, here's another one. I'll write this one down a little bit shorter. What do we get for our first diagonal, everybody? We have 28 minus the second diagonal. So get in the habit, do your first diagonal, write the minus sign before you even start to look at the second one. Now, what's the second diagonal? Now we can put that in, and what do we get for our answer now, everybody? Now, if I had had a -15 instead, I would have written down 28 minus, and then you could either have done minus the -15, or you could have done 28 minus, and then you got a -15. You could have done it like that. But write that minus sign before you start calculating your second diagonal. I find it really helps me make way fewer plus and minus errors. Let's make it a little bit harder. Not everything is a number this time. And we have equals on the other side, which means we've got an equation and we can solve it. So we're going to simply take our first diagonal, which will be the x plus 4 times 4 minus. Got the minus sign written down before I even look at the second diagonal. And everybody, what is my second diagonal? Which gives me 6 equals 18. And so let's see, I've got a 4x plus 16. And I know I'm going to have to get everything over on the right-hand side. So if I go ahead and add the 6, I've got 24, right? And then let's get the 16 over there as well. So let's subtract 16, 4x equals, so x equals. So you liking this today so far? Yeah. All right. Well, let's do one that's a little bit harder then, since that's too easy for you. Let's have x in there in a couple of places. It's not that bad, is it? So first diagonal, I'm going to have x plus 4 times x plus 2 minus my second diagonal. So write down the minus sign and then figure out the second diagonal. What's the second diagonal, everybody? And that has to equal -5. So I need some help foiling this thing. Ian, would you help foil it, please? Everybody good with that? Yep. And I know I'm going to have, since it's a quadratic, I need to get it equal 0. So I'm going to go ahead and bring the 5 over so that I have minus 10. So now I've got x squared plus 6x minus 2 equals 0. So I have this quadratic, which means I need to factor complete the square quadratic formula to be able to solve it. So factoring's easiest, so let's take a look and see, do we think it's factorable? Multiply to be negative 2 and add to be 6? No, if it's not factorable, we are not going to have rational answers. We're either going to have square roots or imaginary numbers in there. Would you rather complete the square or use quadratic formula? Okay, I heard more quadratic formulas, which happens to be what I like better. So we'll do it that way. X is the opposite of b, so what do I write down? Plus or minus the square root of b squared. Minus 4, what's a? So I don't need to mess with that c. All over, you said a was 1, so all over 2. So negative 6 plus or minus, what's 36 minus 8? Or 30, I'm sorry, 36 plus 8. All over 2. And can we simplify root 44? What does it become? And everything is even, so I'm going to take negative 6 divided by 2 is negative 3, and cancel that one, and negative 3 plus or minus root 11 for my two possible answers. Questions there?